Okay, guys, what we're going to be talking about today is Chapter 9, Section 5, volume of pyramids and cones. First, let's talk about the amount of stuff we can fit inside of a pyramid. Okay, so we're looking at number one. The base is a square, so that's a square pyramid. Okay, so the way I like to describe the volume equation, by the way, is going to be volume equals area of the base times the height divided by 3. So the way I like to describe volume is what shape are we stacking and how high are we stacking that shape. So right now we're stacking squares and number one because the base is 11 by 11, so we're stacking squares. How high are we stacking them? We're stacking them 6 high. The reason why we're dividing by 3, because if I tried to draw a prism, if you will, it may not look great, by the way, but play along. If I tried to draw a square prism there, okay, and ask you the question of, hopefully you could see in that prism that I just constructed that there's a lot of empty space there. And if I asked you how many extra pyramids could we fit in that empty space, assuming we took the same pyramid that you see, turned them upside down, and stuck them down inside of that prism, how many more could we fit? I'm hoping you could start to look at it visually and say, well, I think we could fit 2 more of those pyramids in there for a total of 3 pyramids in that one prism. So therefore, because we can fit 3 of those pyramids in that one prism, we must divide by 3 for the volume of a pyramid because 3 of those pyramids fit in that one square prism, if you will. Okay, so we're stacking squares, we're stacking them 6 high, and we're dividing by 3. So our volume here is we're stacking squares, so 11 times 11. We're stacking them 6 high, and then we're going to divide by 3 at the very end. So we got 11 times 11. Okay, it's going to be 121. So we got 121 times 6 divided by 3. Then 121 times 6 is going to be 726 divided by 3. And then so the volume of that pyramid there is going to be 242 cubic inches. So the volume of that prism at number one is going to be 242 cubic inches. Okay, let's move on and maybe look at another one. Let's look at number 2. I'm looking for my calculator. Can't find it. Okay, if we go back and look at number 2 now. Okay, again in number 2, this is a rectangular pyramid. So in this case, we're stacking rectangles. We're stacking the rectangles 5 kilometers high, and then we're dividing by 3. So we're going to stack rectangles. We're going to stack them 5 high, and then divide by 3. 9 times 7 is 63. So we got 63 times 5 divided by 3. 63 times 5 is 315 divided by 3. I apologize why I wrote divided by 5 right here. I'm not sure, but I'm falling asleep. So we got 63. So we got 315, a third of that. Okay, so our volume is going to be 105 cubic kilometers. So the volume in number 2 is going to be 105 cubic kilometers. Volume is always cubic. We're talking about area. We're talking about square units. We're talking about volume, cubic units. Cubic units. Okay, number 3. Number 3, we're stacking triangles. We're stacking triangles 8 yards high. We're dividing by 3 because 3 of those triangular pyramids would fit in one triangular prism if I had constructed that one again. So the volume here is going to be, we're stacking triangles. Now, if we draw the base here of this triangle, our dimensions are 6 yards here, 8 yards here, and 10 yards here. Remember, if we're stacking triangles, we need to find the area of a triangle. And the area of a triangle is the base of the triangle times the altitude divided by 2. Then we're stacking them 8 high. Then we're going to divide by 3. This is where students usually get lost in finding the area of the triangle, where they were like, well, which two segments are the base and the height of the triangle? Where the two segments that are perpendicular, wherever those segments are, become the base and the altitude of the triangle. So the 6 and the 8 are perpendicular. They form the right angle. So the area of the triangle is going to be 6 times 8 divided by 2. And then we're stacking those triangles 8 high. Okay. Then we'll divide by 3. So the area of the triangle is going to be half of 48. Half of 48 is definitely 24. So we got 24 times 8. Then divide that by 3. So 24 times 8. It's going to be a third of 192. It's going to be 64. Forget the units. 64 cubic yards. So 64 cubic yards is the volume of that triangular pyramid. So in that case, we were stacking triangles. And we were stacking them 8 high. Okay. Okay, moving on to finding the volume or space inside of a cone. So when we talk about finding the volume inside of a cone, we're talking about stacking circles. Okay, if we look at number 4, we're stacking circles. We're stacking them 14 meters high. Now, once again, if I were to draw a cylinder, and then ask you to take a look inside of that cylinder, and then hopefully you would notice that there's a lot of empty space inside of that cylinder, and I asked the question, how many more of these cones could we fit inside of that empty space? I'm hoping you could say 2 more cones would fit in there for a total of 3 cones. Therefore, when we're finding the volume of a cone, it'd be very similar to finding the volume of a cylinder, but we're just going to divide by 3 because 3 cones fit into 1 cylinder. Okay? So our volume formula, okay, is we're stacking circles, and we're stacking them 14 meters high, and then we're going to divide by 3. Okay, so we're stacking circles. So pi r squared. Okay, we're going to stack them 14 high, and then we're going to divide by 3 at the end. The diameter of this circle is 14 meters. Therefore, the radius is half of that, 7 meters. So the radius is 7 meters. So we're going 7 squared times 14 pi divided by 3. 7 squared is 49, so we got 49 times 14 pi divided by 3. And then we got 49 times 14, which will give us 686. So we got 686 pi divided by 3. And if we take a third of 686, it's going to be 2. Okay, this is going to be a decimal, I think. So a third of that, 680. Okay, it's going to be 228.7. 228.7 pi cubic meters. Cubic meters. So the volume of that cone is 228.7 pi cubic meters. Again, if you wanted to round that answer, you could, in your calculator, take 228.7 times pi. If you want to convert it that way as well, I like to leave the answers in terms of pi, or you could take 228.7 times 3.14. Either way, I like to leave all the values in terms of pi when they have a pi in it. Okay, number 5. Again, we're stacking circles. In this case, we're stacking them 4 high. We're dividing by 3. So we're stacking circles. And we're stacking them 4 meters high. A third. The radius of the circle is 2 meters. Okay, so we got 2 squared times 4 times pi divided by 3. So 2 squared is 4. Okay, times 4 times pi divided by 3. 4 times 4 is 16. So we got 16 pi over 3. If you wanted to convert that, you could actually leave it like that. Put cubic meters if you like, or you can divide 16 by 3 and round if you like. It's going to be 5, 15, 10, 10. I think 5.3, oops, excuse me, I think that's approximately 5.3 if I got that right. 5.3 pi um, cubic meters. So 5.3 pi cubic meters. Okay. Or if you wanted to, again, you could take 5.3 times pi. I like to leave my answer in terms of pi, or you could take 5.3 times 3.14 cubic meters. Um, I believe that's all. Yep, that's all review stuff. So today we're just talking about the volume of cones and the volume of pyramids. Thank you for tuning in with us today.